Welcome back, folks. In today's class, we'll continue talking about the electric field. And here we are given a question in which there is a charge A is given to me and charge B is given to me. The magnitude of the charge B is 1.5 times 10 raised to the power negative 6 coulomb, and charge A is negative 1.2 times 10 raised to the power negative 6 coulomb. And at point P, we wanted to find the net electric field because of the charge A and B. So it's clearly a 2D problem. So because of B, the electric field lines will be outwards like this. Again, repeating from the previous lecture, if it is a positive charge, electric field lines will be outward. If it is a negative charge, electric field lines will be inward. So because of A, it will look like something like this. Let me sharpen up the pencil. Yeah, so that's how it's gonna look like. Now we wanted to find the magnitude of these two. So EA, the value of EA will be equal to, it will be KQ1 divided by R square. So K value is 9.00 times 10 raised to the power 9 multiplied by 2.10 times 10 raised to the power negative 6. Notice I haven't taken the negative sign. Negative sign is just to tell me the direction of the electric field, which is inwards towards A. And then the distance is given to me 4.00 times 10 raised to power negative 2, and then I'll square it. Now once I'm going to do the calculation for this one, this value will come out to be 1.180 times 10 raised to the power 7 Newton per coulomb. Then after this, I'll try to find out EB. So EB value, again, this will be KQ2 divided by R square. So this will be 9.00 times 10 raised to the power 9 multiplied with 1.5 times 10 raised to the power negative 6 divided by 3.00 times 10 raised to the power negative 6, and then I will square it. And that's going to give me the number as 1.498 times 10 raised to the power 7 Newton per coulomb. So we got the value of EB2. Now I'll mention these two values down here. So this value is 1.498 times 10 raised to the power 7, and this value is 1.180 times 10 raised to the power 7 Newton per coulomb. Newton per coulomb. Now I'm going to draw both of them separately so that we can visualize them properly. So the blue one is like this. This is the blue one, and then this is the green one. The green one is like this. And again, one more time, 1.498 times 10 raised to the power 7. And this value is 1.180 times 10 raised to the power 7 Newton per coulomb. Newton per coulomb. And this is point P. Now I'll try and find the component of these two vectors. So for the blue vector, the component will be in this direction, one component, horizontal component, and vertical component will be upwards. For the green one, the component, one component will be in the west direction, other component will be down in the south direction. And we will try and find out these components. To find out these components, we need to know the angle also. So I'm going to go back into the diagram. Here, there is a piece of information which is missing in this diagram, which I'll mention it right now. So this angle is 36.9 degrees, and this angle down here is 53.1 degree. So if I try and do a little bit of geometry here, and these two angles, these two angles will be the same. So if this angle is 53.1, this angle will be 53.1, and if this is 36.9, this angle will be 36.9 degrees, and this is 53.1 degrees. So I'll mention them down here also. So this angle is 53.1 degrees. This angle is 36.9 degrees. So we figured out both the angles. Now we will try and find the components. So the component of this is EA, this is EB. So component of EA will be equal to, in x direction, first of all, 1.180 times 10 raised to the power 7, and this will be cos of multiplied by cos of 36.9 degrees. Let me just check the angle one more time. Yeah, it is 36.9 degrees. And the same way, EB value will be EAY, sorry, will be equal to 1.180 times 10 raised to the power 7, and sine of say 36.9 degrees. Now, if I see these two components, this is in the west direction. So in the west direction, the other component is down in the south direction. So this will be negative. This will also be negative. And once I'm going to calculate the value for these two ones, the value for the first one will come out to be negative 9.436 times 10 raised to the power 6 Newton per Coulomb. And for EAY, the value will come out to be negative 7.085 times 10 raised to the power 6 Newton per Coulomb. One more time, make sure your calculators are in the degree modes. Then I'll try and find the value of EB. And EBX and EBY. EBX value will be negative because this is towards the west side, and EBY value will be positive because this is acting in the upward north direction. So that will be equal to 1.498 1.498 times 10 raised to the power 7, and this will be cos of 53.1 degrees. So this angle 53.1, and EBY value will be 1.498 times 10 raised to the power 7 sine of 53.1 degrees. Now EBX value is negative 8.994 times 10 raised to the power 6 Newton per Coulomb, and 1.198 times 10 raised to the power 7 Newton per Coulomb. So we figured out both the numbers. Now I'm gonna just find the resultant. So net X and net Y. So E net X value will be equal to, I'll take these two, both are towards the left hand side, negative 9.436 times 10 raised to the power 6, and negative 8.994 times 10 raised to the power 6. And then I will add them up because both are negative numbers. So the number will come out to be negative 1.843 times 10 raised to the power 7 Newton per Coulomb. And same way, I'll try and find the E net Y. E net Y, that will be equal to negative, negative 7.085 times 10 raised to the power 6, and then the other number is positive 1.198 times 10 raised to the power 7. And if I subtract these two numbers now, because one is negative, 4.896895 times 10 raised to the power 6 Newton per Coulomb. This is the net EY you're going to get. Now, again, I'm going to draw them on a separate diagram. So this is a negative number, and I'll represent it down here. And the other number is a positive number. So positive number will go in the upward direction. So this is how the positive number will look like. So this is 4.895 times 10 raised to the power 6. This number is 1.843 times 10 raised to the power 7. And we just need to find the resultant now. And resultant will be, remember, outwards like this. So this value, I can mention it here. This value is 4.895 times 10 raised to the power 6. And down here, this is this value. And now I have to find the resultant. This resultant means E net. You can call it as E net will be equal to square root of both the values. So 4.895 times 10 raised to the power 6 times 10 raised to the power 6 square it plus 1.843 times 10 raised to the power 7 square it. And then you're going to get the final resultant from here. That's going to come across as 1.91 times 10 raised to the power 7 Newton per Coulomb. And then I can also find the angle. Tangent theta is equal to opposite upon adjacent. That'll be equal to 4.895 times 10 raised to the power 6 divided by 1.843 times 10 raised to the power 7, and then theta value will be tangent inverse of 4.895 times 10 raised to the power 6 divided by 1.843 times 10 raised to the power 7, and then I can find the angle theta, that is equal to 14.9 degrees, and the direction for this one will be north of west. So final value is E resultant is 1.191, 1.9191 times 10 raised to power 7 at an angle of 14.9 degrees north of west. So hopefully you were able to understand this question, and I'll see you with another video. Till then, goodbye.